Core 2 Progress Test, Question 7. Figure 3 shows a design painted on a wall at a karting track. Sign consists of triangle ABC, two circular sectors of radius 2 meters and 1 meter with centers A and B respectively. So this one is 2 and this one is 1. Always write the information on the diagram. Given that AB is 7, so A to B, so the full length here is 7, and AC is 3 there, and angle ACB, so this is 2.2 radians. Now, what does it say? Use the sine rule to find the size of angle ABC in radians to 3 significant figures. We've been given a hint to use the sine rule. And we should remember from GCSE maths that the sine rule should be either A over sine A equals B over sine B equals C over sine C, or sine of the angle over this side is sine of another angle over the opposite side, which equals sine of the other angle over its opposite side. You might want to use a formula this way round and leave your unknown on the top. So, what do we have here? Well, we then have sine of 2.2 over 7, and that must equal sine of theta over 3. Finding the angle, we've now got the angle equals sine to the -1 of, times by 3 lots of sine 2.2 all divided by 7. And that's going to give you an answer of 0.354 radians. Part B. If I move to the other side now, Part B. It now says, show that angle BAC is 0.588 radians to 3 significant figures. It says show. That means we can't use the answer. So, but we know it's a triangle, and a triangle adds up to 180 degrees, and pi is 180 degrees, or the equivalent of pi radians is the equivalent of 180 degrees. So what we can do, now we know two angles, we can do pi take away 0.354, which is what we've just found out, and the 2.2, which we were told in the question, and we end up with an answer of 0.5875. To 3 significant figures, that is 0.588. And that's what we wanted to show. Part C. We now want to find the area. Well, we know that the area is half AB sine C, where A and B are the lengths either side of the angle. So if we substitute our values in, we've now got a half times 3 times 7 times sine 0.588. And that will give us an answer of 5.82 metres squared. You could have used any two sides with the included angle here. I chose to use this one because we are given 0.588 here, and it's safer to use angles and measurements given rather than our previous answers, which we could have made a mistake in. Now we get to the tricky bit. Find the area of the wall covered by the design. Well, the area of the triangle we've just worked out as 5.82. That's all this bit here. And now we want to know the total area. Well, this is a circle, but we want to take away this bit here. So that sector. How do we do that? Well, the area of that large circle must equal the full area, which is 2 pi, take away the angle here. And that angle we worked out earlier was 0.588. That's all over 2 pi. And then we want to multiply that by pi r squared, so pi times 2 squared. If I calculate that into my calculator, I should get 11.39 metres squared. So the area now of the smaller circle. The smaller circle, it is still 2 pi in total, but the angle this time is 0.354 out of a total possible 2 pi. That tells us what fraction of the circle we're calculating, and we want to multiply that by pi r squared again. Calculating that gives us 2.96 metres squared. So to find the total area, we just add up these three values, 1, 2, 3 values, and we should come up with a value of 20.17 metres squared. And that is our final answer, which would be, does it say to 2 decimal places? No. So 20.17 metres squared, or 20.2 metres squared, and that's the final answer you're after.